Hi there, Mr. Sutton here, bringing you the AB Calculus 2-8 Part 1 homework solutions on rate of change. On this problem, we're given the function x squared minus 4x, and we're trying to find the slope of a secant line, the equation of a secant line, and some other stuff on the next slide. Let's start with slope here. That's going to use the AROC formula. So I'm going to have f of 3, which is 3 squared minus 4 times 3, minus f of negative 2, so negative 2 squared minus 4 times negative 2. And notice I have a big parentheses for all that, all over 3 minus negative 2. So just a whole bunch of number crunching. And if all they wanted was just an expression for AROC, you could actually leave it like this on the AP exam and it would be fine, because it's all constants. But let's go ahead and crunch the numbers for answer matching purposes. So we've got 9 minus 12, so negative 3. Over here, this is 4 plus 8, so 12, and we're subtracting that from negative 3. And down here we have 3 plus 2 for 5. So negative 15 over 5 gives us negative 3 for the slope. Next, for the equation of a secant line, we'll start with our point slope form here. The m value is this negative 3 that we just found. For the x1 and the y1, I'm just going to take one of these x values, say negative 2, and plug it into the function. So if I do f of negative 2, that's going to be 4 plus 8, so 12. Plugging all this in now, we've got y minus the y value 12 equals the slope for AROC of negative 3 times x minus the x value we plugged in, so minus negative 2, or x plus 2. For this next problem part, using that same x squared minus 4x function, we want an expression for the slope of the tangent line at x equals 1. So I'm going to start with my IROC formula here, f of x plus h minus f of x over h, limit as h approaches 0. And now, in this case, I'm plugging 1 in for x, so this is 1 plus h over here and 1 over here. And the f function is just squaring things and subtracting 4 times the thing. So I can write then 1 plus h squared minus 4 times 1 plus h. So that's the f of 1 plus h part of this. And now we're going to subtract the function itself with 1 plugged in. So I'm subtracting 1 squared minus 4 times 1. All that over h as h approaches 0. And they just set an expression for the slope. Well, here it is. We had to plug in more than just this general IROC formula, but once you've plugged in the x value and you've actually applied the function, you are done with that part of the question. We don't actually need to evaluate it. Now, on this next part, the equation, we want the equation of a tangent line at x equals 1 if the limit in part C equals negative 2. So they're already giving you the limit of all this stuff, so you can use it on the next problem part. So using our point slope formula here, we've already got the m value. It's the negative 2 that they just gave us here. We need an x1 and a y1 though. So plugging 1 in, we're going to have 1 squared minus 4 times 1, which comes out to negative 3. So now I've got y minus negative 3, or y plus 3, equals the slope they gave us of negative 2, that's the instant slope, times parentheses x minus 1. And finally, they want the normal line at x equals 1. This is going to be exactly the same as the tangent line, same point, except that we're using the opposite reciprocal slope now. So I've got y plus 3 again, and now instead of negative 2, I'll have positive 1 over 2, still multiplying by x minus 1 though. For this problem, we're given the function x squared, and we want the slope of a secant line over the interval 2 to 5. So we essentially need to do our AROC formula here. So f of 5 minus f of 2 over 5 minus 2. So that's going to be 5 squared minus 2 squared over 5 minus 2. 25 minus 4 over 3 ends up giving us, 21 over 3, which is 7. And now the equation of the secant line over that same interval, we've got the point slope formula here. we just found the slope of 7, but we need a point. I'm just going to plug in the x value 2. Plugging that in gives me the y value 4. So now I can use that for my point. So I'm going to have y minus 4 right there equals my slope of 7 times x minus 2. For the next problem part on this one, we want an expression for the slope of the tangent line at x equals negative 2. So basically, we just need to set up the limit form of IROC. Here's the original IROC formula, f of x plus h minus f of x over h as h approaches 0. So now for the x value, they're telling us to plug in negative 2, and the f function is just the squaring function here. So we can write negative 2 plus h squared minus negative 2 squared over h. Limit of all that as h approaches 0. So that's the expression they wanted. Now for the equation of the tangent line, given that the limit in part c equals negative 4, we'll start with point slope. We've already got a limit of negative 4, so that's the m value. For the point, we're going to plug negative 2 into the function. That gives us 4 for the y value. So I've got y minus 4 equals our slope of negative 4 times x plus 2. For the equation of the normal line, remember, is perpendicular to the tangent line and goes through the same point. So we still have y minus 4. And now the difference is, since it's perpendicular, we're going to have the opposite reciprocal slope. So this will be positive 1 over 4, and all that times x plus 2. On this problem, we're being asked to take the function square root of x plus 3 and do the following here. So our first task is finding AROC, average rate of change, on the interval from negative 2 to 6. To figure this out, we're basically using the slope formula. So we're doing y2 minus y1 over x2 minus x1. For y2, we're basically taking the second x value, plugging it into the function. So you've got square root of 6 plus 3 minus y1, we're doing square root of negative 2 plus 3. So basically just f of 6 minus f of negative 2. All that over the x values, so 6 minus negative 2, or 6 plus 2. So we've got square root of 9, which is 3, minus square root of 1, which is also 1, all over 8. And this is going to be just 2 over 8, which reduces to 1/4. Now for the equation of a secant line, we have to use the point slope formula. So y2, or y minus y01 equals m times x minus x1. This one right here. So for y1, we basically need to figure out the y value that goes with one of these x values. And it doesn't really matter which one you use. I'm going to figure out the y value that goes with x equals negative 2. So if I do f of negative 2, that's just the square root of negative 2 plus 3, which we already did up here. It was 1. So f of negative 2 is 1. The m value, that's just going to be the average rate of change that you found. The secant line slope is just the average rate of change of the function. So we're going to have y minus the y value we just found of 1 equals the slope we just found of 1/4 times x minus the x value we plugged in, which was negative 2. So this would be x plus 2 then. For this part of the problem, we're being asked to write an expression for the instantaneous rate of change at x equals 13. So I like to start with writing the general formula, which is IROC equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So we only have to do two things to use this formula to write an expression for IROC, and one of them is to plug in the x value 13 for x. The other is we have to actually apply the function radical x plus 3. So we're going to be basically plugging x plus h in wherever we see x in this function, and then we're going to replace the x in the x plus h with this 13. So I'm going to be doing, let's see, square root of 13 plus h plus 3 minus square root of just 13 plus 3. All of that over h, and still got the limit as h approaches 0. And this is it. This is an expression for the instantaneous rate of change. Basically figuring out the slope as the distance between these two things gets smaller and smaller and smaller. Next part, for this one, the equation of the tangent line they want at x equals 13. if the limit in part C, that's this part here, has a value of 1/8. So they didn't ask us to evaluate this at this point, but they did give us the value. So to write the equation of a tangent line, we'll rely on point slope, y minus y1 equals m times x minus x1. And for the y1 value, that's just going to be the y value when x is 13. So that would be the square root of 13 plus 3, which is the square root of 16, comes out to 4. So now putting it all together, we have y minus 4 equals, well, we just said the slope should have been 1/8 for the instantaneous rate of change for the tangent line. So that's going to be 1/8 for our m value, and then we have x minus the x value, 13. There's our tangent line. Next up, they want the equation of the normal line. That's the line that is perpendicular to the tangent line. So it's going to go through the exact same point. We're still going to have y minus 4 and x minus 13. The only difference is we now need the opposite reciprocal of the tangent slope. So instead of positive 1/8, we're going to have negative 8/1, or just negative 8, to go with the y minus 4 and the x minus 13.